Welcome to Lab 6 for EE487 Embedded Systems Development. This will be a short demonstration on how to spawn your gazebo world for line following using computer vision. So in the left-hand side we have the Programming Robots with ROS textbook. This is the original textbook that was designated for the course. And Chapter 12 does a thorough job of describing OpenCV, which is Open Computer Vision, which is a number of techniques for processing images, if it's color or edge detection or change detection, or classifying objects. And so there are many computer vision techniques, and there are courses that are designated or solely allocated just for computer vision. So for this lab, we are simply looking at a small subset of all of those techniques. So one, you will demonstrate how to detect a line, how to detect the center of a line, and then generate an appropriate twist message for the robot to follow that line. So that's the goal for this lab. And what you will also do is then look at other alternatives or other techniques that you can use to generate line following behaviors and algorithms. So again, Chapter 12 really goes through the the entire methodology. Of course, we'll be spawning a gazebo simulation, and once that simulation is running, the main topic that we will be looking at is camera RGB image raw. So that image topic is what we will process, and then we will generate a twist message again to generate the appropriate linear and angular velocity to follow that line. So I'm not going to go through the entire chapter in this demonstration, but mostly to show you how we will generate the actual package that we'll use for this particular lab. So this is under the West Point Robotics GitHub repository, and it's called ROSbook. So this again is a series of packages and tutorials that are associated with the textbook. So this has been forked and stripped down to really focus on the line following package that's part of this the textbook and the tutorial. So again, in the lab 6 PDF, there's a link to where this is located. If you simply search for West Point Robotics GitHub, that will typically be the first link. You can see here, GitHub/West Point Robotics/ROSbook. If we go back to West Point Robotics, it is the first package. Of course, if something between now and when you execute the lab, if it is updated, then this may not be the very first one. But it's called ROSbook. So within ROSbook, again, I have a number of instructions on how to properly clone the repository and then launch the actual world that's in question. So going to our ROS repository or our ROS virtual image, I'll just go ahead and, assuming that I've already cloned the repository, I've done cat can make, I will now just execute the launch file for generating our gazebo simulation. So here is our waffle pie robot, our Turtlebot 3. I'm just going to change the perspective or of the view just so you can see how the actual robot looks like on the test track. I'm then going to use a left click and zoom in on the robot itself. So here's our robot, and then positioned on a yellow line, right? So this is a fairly predictable line that is allowing us to ignore a lot of the inconsistencies we may see on an actual road where the line may not be have the same type of pattern. So this is this line is a simple single track, and that we'll be able to have generate a good image from it to be able to track. So we have our gazebo simulation running. Well, let's go ahead and test to make sure that the actual robot itself is able to be moved. So I'm just running the Turtlebot 3 teleop Turtlebot 3 keyboard launch or teleop key launch file, and again, this simply provides us the opportunity to interact with our robot using the keyboard. So here's our actual key presses. So I'll just go ahead and just drive the robot forward, and we see in our gazebo simulation that it moves. Another option that we can actually do is we can actually run our QT view or image view that we've done in the past. So I'm just going to drag this over. So if I do ROS run RQT image view, right, and run that, what I actually see here is the perspective of the robot. So here is the yellow line from the Pi camera that's on the robot itself. So if I just move this out of the way. So again, this is from the perspective of the robot, and then if I drive forward, we can see both the robot itself is driving down the yellow line, and in the image view we also see that it's changing as the robot traverses the track. So I'll just go ahead and stop that. Again, I almost drove off the track, so I'm gonna move left a little bit. Now, one thing to realize, when you write your script, so you are going to subscribe to this actual topic. So this is the topic is camera RGB image raw. So that is the topic that your script will be would be subscribing to. Then what you are going to publish is to command velocity. So here, again, I'm providing velocity commands or a twist message using the keyboard. Your Python script will take the image view and process it, and then generate a velocity message. So that's really for the demonstration purposes, the majority or the large portion of this lab is to do that. So what I'll do is I'll go ahead and stop the keyboard teleop option, and then there are many options or many ways to implement computer vision and generate twist messages. Again, you're going to focus on one and then write about two others. So looking at 3 in total. I'm going to use a very common line follower script, and run that, and what you'll see is the robot itself So there you see in the to the right, the robot itself is moving. Here is the window that appears to basically determine how or the center point of the actual line. And to the right, I'm trying to minimize this. You can see the actual robot itself moving. So this is what the robot sees. The red line or the red dot is really the calculation of the center point of the yellow line. And on the right hand side, you see the robot basically navigating this yellow line. So again, as we're hitting really this first turn here, and and then seeing how the robot itself is navigating the course. Again, I'll go back to the CV window, right, showing how the robot is actually executing, or how it's calculating the center point, and then you see here the robot navigating the course. So with that, I'll end the tutorial. But again, this is really subscribing to the image view, and then or subscribing to the image topic, and then generating a velocity command. And this is all done autonomously, so I'm not, of course, generating any messages myself to allow the robot to navigate.